Hello dear student, this is a last lecture from the second topic of unit first from chemistry paper second in semester second. Okay, so this topic we are going to focus on what are the electromagnetic radiation, how that electromagnetic radiations are useful for the detection or the qualitative and quantitative analysis of any substance, how that electromagnetic radiations affect on the atoms and the molecules, okay, and how different techniques are developed with the help of the interaction of electromagnetic radiation with the matter for the analysis purpose. Okay, so if you see here, what happens whenever any electromagnetic radiation falls upon the atom or the molecule, the different things happen over there. Different things happen over there. What things happens? Either the light which is falling or the energy which is falling upon the molecule, that is absorbed, that may be the emitted after some time, that may be scattered, okay, that may be the, these are the things happens over there. So accordingly, we are going to see the one by one technique. Okay, so fluorescence is the phenomenon actually over there. That just focus these three things: absorption, emission, scattering, and transmission. Okay, these are the things happening over there. Absorption. What happens when there is a source of light? Okay, when the incident light I0, this is intensity of incident light, will fall upon a sample containing atom or molecule. So the light is some of the light is get transmitted, and the transmitted light is detected in the detector. So this is intensity of incident light. IT is the intensity of transmitted light. The intensity of absorbed light. Intensity of absorbed light is given by I0 minus IT. What is I0? Is the intensity of incident light. IT is the intensity of transmitted light. So by subtracting intensity of transmitted light from the intensity of incident light, whatever light is absorbed, that amount you are getting over here. Okay, that is intensity of absorbed light. Okay, and that absorption is proportional to the concentration of absorbing species, and this is very clearly and finely explained by the Beers-Lambert's law. Okay, Beers-Lambert's law, and the technique used for this is a absorption spectroscopy. As we are studying absorption, so that the technique is called absorption spectroscopy. Now, emission. See, the incident light fall upon the sample. Some of the light is get absorbed by the sample. Now, that light may be instantly emitted, or that light may be emitted after a certain period of time. Now that depends. Again, there is two techniques in that. So here the sample acquires the energy or any form of energy. Here they are saying thermal energy, and get excited. Then emits the radiation whose intensity is proportional to the concentration of emitting species. Okay, so emitting radiation is again detected with the help of detector. Okay, energy of sample is decreased during the emission, and the measurement of emitted light is measured as a function of concentration of emitting species, and the technique is called emission spectroscopy. Emission spectroscopy. Okay, now we'll see what is the scattering over there. So scattering of radiation occurs in the case of heterogeneous systems having more than one phase. There is a suspension or colloid dispersion. Okay, a part of incident radiation I0 is scattered by the suspended particle present in the suspension medium. Okay, and remaining is transmitted. The scattered radiation is given by IS it can be observed at any angle of incident radiation, and the technique is called as a scattering spectroscopy, you can say. The scattering spectroscopy, see now what happens over there. The scattering or scattered radiation IS and transmitted light radiation IT are proportional to the concentration of scattering species present in the suspension, as you know that. Okay, the technique nephelometry involves the measurement of intensity of scattered light, and the technique turbidimetry involves the intensity of transmitted light. Intensity of transmitted light. Okay, turbidimetry मध्ये तुम्ही काय करताय, इंटेन्सिटी ऑफ ट्रान्समिटेड लाईट मेजर करताय. नेफेलोमेट्री मध्ये इंटेन्सिटी ऑफ स्कॅटर्ड लाईट त्या ठिकाणी मेजर करणार आहोत. ओके, कुठून स्कॅटर होते, कुठून ट्रान्समिट होते, या सॅम्पल मधून, आणि त्याच्यावर येणारी इंटेन्सिटी काय आहे, I0 जी की इंटेन्सिटी ऑफ इन्सिडेंट रेडिएशन. ओके, now what is fluorescence? If the absorbed light is instantly given out and that given out radiations are measured by certain instrument or detector, that phenomenon is called as a fluorescence. If the certain time is required for the emission of absorbed radiation, that is called as a phosphorescence. Now what is a fluorescence? How much time is required if the absorbed radiation is given out in the 10 raised to minus 8 second? That is called fluorescence. 10 raised to minus 8 to 10 raised to minus 4. थोड़ा time लागत असेल emission ना, that is fluorescence. And if the time required is more than 10 raised to minus 4 second to few seconds, that is called phosphorescence. Okay, phosphorescence is also called delayed fluorescence. Delayed fluorescence. Okay, so this is what the pictorial, or you can say the block diagram for the representation. Source of high energy radiation, use incident radiation on the sample. Okay, and the fluorescent radiation are measured with the help of detector. The fluorimetry, the technique is called fluorimetry. And phosphorescence measures measurement-साठी जे technique वापरतात त्याला म्हणतात phosphorimetry. These two technique you are going to learn in F.Y.B.Sc. Okay, so far whatever you have studied, remember, so far whatever you are studied, everything you are going to learn in detail in the further higher classes. Okay, so this is what we are learning here is just an introduction to the different techniques. Okay, so fluorimetry, see, fluorimetry, as I said, as I told you, you are measuring the fluorescence. Okay, and phosphorimetry, you are measuring the phosphorus. Okay, now see here in the diagram, atoms are studied by absorption spectroscopy, emission spectroscopy, then fluorescence and scattering. While the molecules are studied by absorption spectroscopy, fluorescence technique and scattering. Okay, you cannot study by the emission spectroscopy. Okay, this is what just a brief over here. Now, what things happen when any electromagnetic radiation interact with the matter of the atom? Either there is a transition of electron from lower energy state to higher energy state, there is a vibration of atom about their mean position, okay, there is a rotation of molecule about its axis. So total energy is now given by E electronic plus E vibrational plus E rotational. Okay, and as we know that according to Planck's constant quantum theory, the radiation or the energy transfer in the form of quanta, in the form of bundle, in the form of bundle. That is not continuous process. That is a quantum process. Okay, or the bundle that travels in the form of bundle. If you see here electronic energy levels, if you see these are the electronic energy levels E1, E2, E3. जेव्हा एनर्जी ऍब्सॉर्ब करतो है ना, atom किंवा molecule energy absorb करतो, it undergoes excitation from ground state to the excited state. So the difference is given by the absorbed energy is given by E2 minus E1. Okay, energy of this state upon energy of this minus energy of this state. Okay, so E absorb is given by H nu absorb, that is equal to H C upon lambda of absorption light, that is equal to 8 into 10 raised to minus 19 joule. Okay, so the energy difference between two neighboring electronic level is of order of 5 electron volt. Okay, that is 5 into 1.6 into 10 raised to minus 19 joule. That will become equal to 8 into 10 raised to minus 19 joule. Okay, so accordingly, we can study the molecule. Okay, now this is just more detail regarding the energy levels. See, if you see here to this side, these are the electronic energy levels. In the electronic energy level, there are vibrational energy levels. See, in the E1, in between E1 and E2, there are the vibrational energy level, that is V0, V1. These are the vibrational energy levels. Okay, and in the vibrational energy level, there are the rotational energy level. There are the rotational energy level. Okay, therefore E electronic is more than E vibrational, and E vibrational is more than E rotational. Okay, so this is what you can see from the diagram. Okay, once there is an electronic transition taking place in a molecule or the atom. Okay, these are the things. These are the things associated with that molecule. Means there must be the vibration in molecule. There must be the rotation of molecule. Once the electronic transition back. Okay, and you can study that molecule very clearly how it is responding to the absorbed energy or the radiation. Okay, so there are the type of molecular spectroscopy. As we have discussed earlier, that there is electronic spectroscopy, then there is a vibrational spectroscopy, and then there is a rotational spectroscopy. Okay, so in the electronic spectroscopy, the molecular study is carried out in UV visible light. Okay, in vibrational spectroscopy, the study is carried out in near IR and mid IR region. Near IR and mid IR region. And in the rotational spectroscopy, study is carried out in far IR. Okay, so this is all about the topic spectroscopic technical molecular spectroscopy. This is whole topic is just giving you the brief regarding the different techniques and how that techniques are useful for carrying out the analysis of molecule or study of molecule. Remember, whatever we are learning here, that is just to qualitative, just to carry out qualitative and quantitative study of chemicals, okay, or the substances. Okay, even the study of corona is also carried out with the help of chromatographic technique and different tests they are carrying out. RT-PCR test is there, body temperature measurement is there. So these are the techniques which are very much relevant to the chemistry. Okay, as a coronavirus is also a form of different chemicals. Okay, that chemicals are, that corona body is made up of different chemicals. The RNA is there, then glycosides and the different things are there. So to study that chemicals, okay, these techniques are. Thank you.